This is a video response to Randy Powell and Marko Rodin and all those people who have been talking about Vortex Based Mathematics. Looks like pretty interesting stuff, but I think I've discovered something even more special. I mean, their Vortex Mathematics, they claim that, well, they're doing about end world hunger, curing all diseases, infinite energy, perpetual motion, everything. And I mean, that's vortex-based mathematics. And I've discovered something even better. I mean, this is good. This is really good. It could put an end to, well, not an end to the world, that'd be a bad thing, but gosh, an end to all worries, all boredom, all fear, all panic. I mean, really, this is some good shit. Anyway, so let's get on to it. You might have recognised the well, this is scribbling, we'll ignore that. The vortex thing with the little figure of 8 debris and the numbers on the edge and all as a circle. Now, what I've discovered actually rearranges that. I think that circle is sort of inadequate to what I found. Because what I've discovered is if you actually arrange the numbers like this, so you've got a 9, 3 and 6, put these in at the start, then this is where it really kicks off, because you've got the 3, the 6 and the 9, and as we know, 3 plus 6 equals 9, that's a really good thing, and 9 minus 3 is 6, that's also quite cunning, and 9 plus 6 is, well, something bigger than 10. Anyway, but 3 and 6 and 9, that's the important thing. And if you look at this line here, it forms a figure of 8 around the 3 and the 6, because as we know, you keep adding 6 and 3 together, you keep getting 9. But that's a figure of 8. 8 doesn't figure into this yet. Although 3 is a bit like half an 8 if you added another 3. Anyway, that'd be 8. But this is the figure of 8. That's in the infinite loop. Keeps reflecting back and forth, missing out 9. 9 is unconnected. It's just 6 and 3 back and forth, 6 and 3 in this infinite loop. Now what I'll do, I'll just add the other numbers on. I've got it redrawn here. Hopefully you can see it. I'm afraid my materials are a bit limited on budget here. Okay, so this is the full number grid, and it's not a circle. You see, it's a diamond, and that's important. That diamond is important. So I filled the other numbers in. I've got the 9 and 3 and the 6, but I've also had the 1 and 2, 4, 5, and then the 7 and 8 here. Now, you'll notice that, well, I mean, we got all the maths is there. I mean, if you add 1 and 2, you get 3. 2 and 3, and you get 5. What is it? 5 and 4, you get 9. That's pretty good. And then 7 minus 2 is 5, and 1 plus 8 is 9. And 9 minus 1 is 8. That's also true. 9 minus 2 is 7. So that goes on to this side here. 3 plus 4 is 4, 5, 6, 7. 7, that's good. It's there as well. It was on this side, so 3 and 4 is 7 here. 6 and 4, 6 is 4 is 10, and 10 is 1, as we know. 6 and 4 is 10, which minus the 9 is 1. So it's all there, the whole thing is there. And then, I mean, this vertical axis is quite unusual. It doesn't appear in the vortex-based mathematics, where you get the 5 and the 4 and the 9 all in a row, vertical line. And that's really, really key here. Oh, I mean, I forgot to say that 2 and 4 is 6, and of course 7 and 4, well, 7 minus 4 is 3. So, I mean, that's how it all links together here. And so, I mean, that was the original thing. So you've got that, again, that figure of 8 around the 6 and the 3, reflecting back and forth, and then the 1 to 8 all around the edges, with the 5 in the middle. Now the 5 is, of course, partly unique because it is half of 10, and 10 is, as we know, also 1, because without the 0, 10 is the same as 1. So the 5 is in the middle, is representing the half, but also the middle, the central the central tenant. Anyway, so what I'm going to do is going to draw this up on the board and just show you something that I've discovered around the edge of this, because I think this spreads out. This isn't just confined just to the 9 numbers. This goes further. So I'm afraid I've written it down on paper, so you'll have to bear with me as I draw it up. Here goes. Hopefully you can see this on the board here. That's my black pen and the red. Okay. Right, so we start off drawing the central column. So we have the 9 here, the 9, the 3, and the 6. There they are in their triangle with the 3 and the 6 infinitely. And then with a green pen I'm marking the other numbers. Actually, no, let's use where's blue eye? I've got a blue on the floor. Got it, found it, that's okay. Okay, putting the other numbers into the central square here. We have the 1 and the 2, and we have the 4 and 5, of course, and then 7 and 8, making this central diamond the 1 to 9. Critical 1 to 9, all the numbers you ever need contained just in this single quadrant here. Now what I'm going to do is expand this out and add in, this is the discovery, the other numbers. So the top here we've got a 6, we've got a 6 and a 3, and another 9 and a 6 and a 6, and look at this, 6 and 6, 9 and 9, all there, focused at the top of the grid. And then we have 3, another 6, 9, 3 and 6, 9, and another triangle here. Got the triangle here, triangle here. Going off this corner here we have another 6. I'm afraid that's not positioned. Oh, I haven't got enough lines. Nope. My mistake. That's better. Just 3, 6, 9. Okay. 6 here. That's better. That's better. 6 and then 3. Another triangle. 3, 6, 9. 3, 6, 9. 3, 6, 9. 3, 6, 9. All there. All surrounded by the other numbers. Down into this corner we've got 3, another 6 down here, another 6 in this, 3, 9, and we have 3, 9, 6 in a line. Got this quadrant here, we've got a line, 3 and 6 and 9, just right there, clear as day. There it is, another 3 over here. Let's go to this corner, we've got the 9, 3, 6 and 9, 3, and then this other 3, 3, 6, 9 is there, it's there. Just here. Then here we go, another 9, 3, 9, 6 and 9 on this one, 6 and 9, 3, triangle here, 3, 6, 9, still repeating around here. And then if we go to this bottom corner, we have another 6, 6, 3, 6, 6, 3, 3, 6, 6, 3, 3. I hope you can see that. Very faint. I apologise for the quality of my markers. I'll try and get better ones next time. 3 and 6, and then the final number here, this 9, right down there. Now, if I can take you perhaps just a little bit closer, so you can see that grid. That is the completed Bailey number grid. I haven't got a name for it yet, so I'm just calling it that. But there it is. That's with all the 3s and 6s and 9s, all their patterns, all laid out. Now, what I can do is just fill in a few more numbers, because I mean this thing is infinite. Just goes on, So what I'm going to do, add the numbers in, if you just bear with me. So 1, 8, 2, 4, 7, 1, 2, 8, 5, 4, 7, 2, 1, 5, 1, 7, 8, 8, 2, 4, 7, 1, 5, 4, 2, 5. Missed a 6. Apologies. Oh, wasn't correct. Now it's correct. 6, 8, 1, 7, 8, 1, 7, 8, 5, 4, 2, 2. That's important. Then we have the 8, 3 and the 8, 3, 5, 8, 4, 1, 7, 2, 7 and 1 again, 7 and 1 making 8, which is over here. 2 and 5 making 7. 2 and 4 making 6. Just incredible, incredible. It just goes on, it just repeats and repeats, and this is how the perpetual motion just, I mean, it's just here, it's contained within this. That's 4 and 5 and 2, and then we have 1 and 7 and 2 and a 5 and 8 and 4, and that is it. That is, no, it's not. And this here, 5. 5 must go there, as I said at the beginning. 5 is the missing link of this central column, this triangle, this diamond shape. It's in the middle of the triangle. There's 5 there, there's a 5 here, there's 5 there, there, and here. There's also a 5 here. There's here, it's everywhere. In fact, I mean, let's count out that. That's 1, 5, 2, 3, 4, 5, 5, 6, 7, 8, 9. There's 9 5s on this grid. 9 5s, and there's 9 5s. I mean, that's pretty incredible. Let's count on 9 because there's probably 9 of these. 9, 2, 3, 4, 5, 6, 7, 8. Where's the one? Where's the last one? Do that again. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. There's 9 9s. There's 9 of every number here. I mean, that's just incredible. And I've got to say at the start, if you go 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 and then plus 9, what do you get? That equals 45. Now, what is 45? 4 plus 5 equals 9. 4 and 5 is 9. That is a central loop. It's all there, contained in one cube. Here it is. And so, I mean, let's have a look at this. You've got numbers 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I bet here. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here. Okay. Get on. In this cube, the numbers 1 to 9, all of them, everywhere. Here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here. Another 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Again, here it is, repeating and repeating again. 1 to 9, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Repeats again, and down here, and down here, down here. Here it is, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Another cube. This one, here it is. There, look. All of them, 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 squares. That's 9 cubes. 9 of these numbers. And then, look. I mean, it goes on. It gets even more incredible, okay? Let's take this 3, 6, and 9 here. 3, 6, and 9. So we have 1 and 2, and then 5 in the middle. 1, 2, 3, 4, 5. Where is it? Where's 6, 6, and then 7, 8, and 9. Through here, we have the numbers 1 to 9. They're there. I mean, it's incredible. Here, look. 1, 2, 3, 4, 5, 6, 7, 8, and 9. It's there. 1 to 9 is there, right across the middle. Right there. This, I mean, this is what I just think is incredible. It's unbelievable. You look at this thing and you think it's just a mass of numbers, and it turns out there's order, there's structure here. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Here, another one. And here again. In fact, even down here, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There. Every one, every row, every diagonal on this board, the numbers 1 to 9. Every diamond in the middle of it, the numbers 1 to 9. I mean, God, I can only go this far. I don't know what it means. I don't know what it means at the end to what we can achieve with this. But I mean, that's where I want to leave it up to you guys out there to study this further, to see if there's more of these diagrams that exist. I mean, potentially there's an infinite number of these repeating patterns. I mean, it could go on here. I haven't drawn it here, but I mean, does it go on here all the way? You know, another set, another 9 nines, and over there and here. I mean, you mount this onto a donut, and God, that's gonna be a tasty dish. So that's why I leave it here. This is what I've discovered. I mean, I don't know what it means. I don't know what it could be used for. I mean, I don't know what happens when you just rub out a couple of these numbers. I mean, is there any way of working out what numbers are missing if you just take a few out? But again, I just don't know. I just don't know what there is. I mean, so I'll leave it up to you as the internet community, to Randy Powell, and all the others, to to Marko Rodin, of course. I mean, investigate this. Perhaps we can, I don't know, change the world.